This video is presented to you by www.testprepadda.com. Dear students, in this session, we will learn trigonometric identities involving the sum of three angles. Okay, first of all, if A, B, C are any three angles, then we will prove first identity related to three angles, sine A plus B plus C is equal to sine A cos B cos C plus cos A sine B cos C plus cos A cos B sine C minus sine A sine B sine C. The interesting part in this identity, you can see first angle sine A and the other two angles cos B cos C. Here second angle is sine cos A sine B cos A. Here the third one is sine and then all three sine. Okay, now the second identity which we will prove here, cos A plus B plus C is equal to cos A cos B cos C minus cos A sin B sin C minus sin A cos B sin C minus sin A sin B cos C. Now third one, tan A plus B plus C, which we write here as tan A plus tan B plus tan C minus tan A tan B tan C upon 1 minus tan A tan B minus tan B tan C minus tan C tan A. So these are the identities for the sum of any three angles. So one by one we will prove all these identities. First of all, sine A plus B plus C. This sine A plus B plus C I can write as sine A plus B plus C. Okay, now I will use here sine A plus B formula. It will be sin A cos B plus cos A sin B. Got it? So in place of A, I'm writing A plus B. In place of B, I'm writing C. So sin A cos B plus cos A sin B. Now open this sin A plus B, two angle identity. So it becomes sin A cos B plus cos A sin B, and here cos C plus open this, cos A plus B is what? Cos A cos B minus sin A sin B, and outside the bracket sin C. If I open this, I get it as sin A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. An interesting identity is proved. Sin A plus B plus C is equal to sin A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. Okay. Now, if I take cos A cos B cos C common, left hand side is sin A plus B plus C. I am taking cos A cos B cos C common. Inside the bracket, since cos B cos C is there, cos A not there. So I'll multiply cos A, divide cos A. And cos A cos B cos C is taken common. So here it becomes sin A upon cos A. Similarly, this part sin B upon cos B plus this part sin C upon cos C. Here nothing is there. So if I take cos A cos B cos C common, I have to divide cos A cos B cos C here. So ultimately it becomes sin A sin B sin C upon cos A cos B cos C. Got it? Now it becomes cos A cos B cos C, and inside it becomes tan A plus tan B plus tan C minus tan A tan B tan C. Got it? Sin A plus B plus C is coming what? Sin A plus B plus C is coming as cos A cos B cos C. Inside the bracket tan A plus tan B plus tan C minus tan A tan B tan C. Got it? Now I will try to get the identity of cos A plus B plus C. Okay, in the same manner. cos A plus B plus C. Here also I'll write it as cos A plus B plus C. Now, I consider this as one angle and this is another angle and consider the summation of two angles. So, cos A plus B. Recall the formula cos A plus B. Cos A plus B was cos A cos B minus sin A sin B. Got it? So, I will write this as cos A plus B into cos C minus sin A plus B into sin C. Okay, now I will open this. Cos A plus B will be written as cos A cos B minus sin A sin B in the bracket, outside the bracket cos C. And the sin A plus B will be written as sin A cos B plus cos A sin B and outside the bracket sin C. Now if I multiply this cos A in this bracket and sin C in this bracket, it ultimately becomes cos A cos B cos C minus sin A sin B cos C minus sin A cos B sin C minus cos A sin B sin C. Now, if you go back and check, the first term was cos A cos B cos C. Here you can see we have proved cos A cos B cos C, and then sin A sin B cos C. Can you find sin A sin B cos C? Yes, I can find. Here it is. Sin A sin B cos C. And then sin A cos B sin C. Sin A cos B sin C. Here you can find let me check here. Here it is. Sin A cos B sin C and cos A sin B sin C. So the identity is proved here. Now, in a similar manner as we did in the previous case with sin A plus B plus C, here also if I take cos A cos B cos C common, if I take cos A cos B cos C common, then cos A plus B plus C will be written as I am taking cos A cos B cos C common, inside the bracket becomes 1 minus. Here I have taken cos A cos B cos C common. Cos C is there, but cos A cos B not there, so I have to divide cos A cos B here. So it becomes tan A tan B. Got it? Similarly here, cos B is there. And since we are taking cos A cos B cos C common, so here I need to divide cos A cos C. So it becomes minus tan A tan C. The last term will become tan B tan C. Okay. So we have got cos A plus B plus C as cos A cos B cos C in the bracket 1 minus tan A tan B minus tan B tan C minus tan C tan A. Okay. This is another interesting identity. Now we will try to find the value of tan A plus B plus C. Tan A plus B plus C. What will be tan A plus B plus C? Tan A plus B plus C can be written as sin A plus B plus C upon cos A plus B plus C. Now I'll substitute the values we have already derived. Here I'll put sine A plus B plus C as cos A cos B cos C into tan A plus tan B plus tan C minus tan A tan B tan C upon I'll write this cos A cos B cos C 1 minus tan A tan B minus tan A tan C minus tan B tan C. This cos A cos B cos C will get cancelled and at the end we will get tan A plus tan B plus tan C minus tan A tan B tan C upon 1 minus tan A tan B minus tan B tan C minus tan C tan A. Got it? So this is tan A plus B plus C. Now if we go back and check the tan A B C, tan A plus B plus C identity, it is the same. Okay, so we proved it. Now one interesting point here is tan A plus tan B plus tan C. It is the summation of one term, only tan A angle, one angle only. So I can write this as S1. S1, one term, it involves one term, minus I can write S3. S3, you can see three angles, multiplication, tan A, tan B, tan C. Upon I can write here 1 minus S2. So tan A plus B plus C can also be written as S1 minus S3 upon 1 minus S2. Okay, dear students, if in the above identities, if I put A equal to B equal to C as alpha. If I put A equal to B equal to C equal to alpha, then A plus B plus C will become what? A plus B plus C will become 3 alpha. Got it? Now, if I substitute in the sign identity, so sin A plus B plus C will become sin 3 alpha, which will be written as, if you go and check the sign identity, it is sin alpha, cos alpha, cos alpha, then cos alpha, sin alpha, cos alpha, then cos alpha, cos alpha, sin alpha. So here you can see all the terms are basically same, right? cos square alpha sin alpha, cos square alpha sin alpha, cos square alpha sin alpha, and sin cube alpha. So 3 cos square alpha minus sin cube alpha. So I get here 3 cos square alpha sin alpha minus sin cube alpha. Okay, and as you know, cos square alpha is what? 1 minus sin square alpha. If I substitute here, it becomes 3, 1 minus sin square alpha into sin alpha minus sin cube alpha. So at the end, it becomes 3 minus 3 sin cube alpha. 3 sin cube alpha, and sin cube alpha is already there. So sin 3 alpha becomes what? 3. Here if you multiply, actually it sin 3 sin alpha. So at the end it becomes 3 sin alpha minus 4 sin cube alpha. Another interesting identity. Sin 3 alpha is coming what? 3 sin alpha minus 4 sin cube alpha. Okay. Now, similarly, I will try to find cos 3 alpha. Again, in the cos identity, I will substitute A, B, C as alpha. It becomes cos 3 alpha. Now, if you go and check cos identity, here I am writing cos alpha, cos alpha, cos alpha. So it becomes cos cube alpha. Here sin square alpha, cos alpha. Here also sin square alpha, cos alpha. Here also sin square alpha, cos alpha. So in the cos 3 alpha, it becomes cos cube alpha minus 3 sin square alpha cos alpha. So what will you write here? Cos cube alpha. I will substitute sin square alpha with 1 minus cos square alpha cos alpha. So at the end it becomes what? Uh, the minus will become plus, plus 3 cos q alpha, and 1 cos q alpha is already there. It becomes 4 cos cube alpha minus 3 cos alpha. Okay, so this way we get cos 3 alpha. Another very interesting identity. Got it? Now, if I try to find tan 3 alpha, tan 3 alpha, tan 3 alpha is what? Sin 3 alpha upon cos 3 alpha. Okay, you can substitute these values here, or even you can directly use the identity of tan A plus B plus C. Okay, so here if I write A plus B plus C as 3 alpha means tan alpha plus tan alpha plus tan alpha. So what is this? 3 tan alpha. Okay, what is this? Tan alpha into tan alpha into tan alpha. It becomes tan cube alpha minus upon 1 minus tan alpha into tan alpha is what? Tan square alpha. Then tan alpha into tan alpha is what? Tan square alpha. Tan alpha into tan alpha is what? Tan square alpha. All equals, it becomes 3 tan square alpha. So tan 3 alpha comes as 3 tan alpha minus tan cube alpha upon 1 minus 3 tan square alpha. Got it? Now here if I try to find cot 3 alpha. Cot 3 alpha will be what? 1 upon tan 3 alpha. Okay, so I can write this as 1 minus 3 tan square alpha upon 3 tan alpha minus tan cube alpha. Now, in place of tan alpha, I'll write 1 upon cot alpha to get the identity in terms of cot. So it becomes what? Equal to 1 minus 3 upon cot square alpha upon 3 into 1 upon cot alpha minus 1 upon cot cube alpha. Okay, so here I'll take cot square alpha as the LCM. So cot square alpha minus 3 here upon, in this case I'll take cot cube alpha as the LCM. So here it becomes 3 cot square alpha minus 1. Now cot square alpha will cancel cot square alpha here, cot alpha will be left out. Now this cot alpha will be multiplied here. Okay, so at the end the result will be what? Cot cube alpha minus 3 cot alpha upon 3 cot square alpha minus 1. This is the value of cot 3 alpha. Another interesting identity. So here we have derived different identities related to sum of any three angles. Okay, dear students, in the next video we will discuss some conditional identities related to three angles. Okay, thank you. This video is presented to you by www.testprepadda.com. testprepadda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.